To find the derivative of tan inverse x, I want to write y equals tan inverse x and then say what is dy over dx. The first thing, we want to take tan on both sides, then tan y equals x, and use implicit differentiation to find dy over dx. The derivative of tan is secant square, so derivative of tan y would be secant square y. But remember, we are not taking the derivative with respect to y, we are taking with respect to x. So we need to multiply by dy over dx. And then this is equal to 1. So dy over dx happens to be just 1 over secant square y. Now, usually we say convert all the secants to sines and cosines. But notice, I want to keep it as secant square. Why? Because x is tan y, and I want to write secant square. I want to recall this Pythagorean identity. 1 plus tan square y equals secant square y. So secant square y could be replaced by this 1 plus, but tan square y is x square. So this is the derivative. Dy over dx is 1 over 1 plus x square. So that's the derivative of tan inverse x. And we'll find the derivative of cot inverse x in a similar fashion. So let's go ahead and write y equals cot inverse x, and then write cot y equals x and use implicit differentiation. Derivative of cot is negative cosecant square. So derivative of cot y is negative cosecant square y dy over dx. It's implicit differentiation. So you multiply by dy over dx is equal to derivative of x is just 1. So dy over dx happens to be negative 1 over cosecant square y. And again, we want to keep it as cosecant square and think of relationship between cot and cosecant square. And we recall this Pythagorean identity. 1 plus cot square y equals cosecant square y, which means dy over dx happens to be negative 1 over cosecant square y could be replaced by this, but this is 1 plus x square. So that's the derivative of cot inverse x. Notice how similar it is to the derivative of tan inverse x. Tan inverse x derivative is 1 over 1 plus x square. Derivative of cot inverse x is negative 1 over 1 plus x square. And this should make sense because there is an identity in trigonometry that if you take the inverse of tan and add it to inverse of cotan, you always get pi over 2. So if you take the derivative on both sides, the right side is 0, which means the derivative of tan inverse and cot inverse, they are opposites of each other.